Okay, so in this video I want to answer the question of whether or not the function f of z equals z squared plus 2z bar is holomorphic at any point z0 in the complex plane. And here f is a function mapping complex numbers to complex numbers. So the first thing I want to do is I want to write z as a complex number. So let's write z as x plus iy. And what my aim is, I want to write f of z as the sum of u of xy and I times v of xy, and here u and v are just the real and imaginary parts of f. So what happens when I make this substitution? Well, I end up getting f of xy, because now my function is of x and y and not z, x plus iy all squared plus 2 times z bar, and z bar is just x plus iy bar. So what happens when I expand this? Well, I'm going to get x squared plus 2xyi plus I squared y squared, and I squared is minus 1, so this is minus y squared, plus 2 times something. Well, x plus iy bar is x minus iy, because the conjugate of a complex number is the same complex number, just with the negative of the imaginary part. So this is plus 2 times x minus iy. So now if I collect the real and imaginary parts together, I should get the real part should be x squared plus 2x minus y squared, and the imaginary part should be plus I times 2xy minus 2y. So there are my real and imaginary parts. So what I'm going to do now is I'm going to write this as u of xy, and this as v of xy. So now I've got my real and imaginary parts, just like I originally wanted to in the beginning of the question. So what I want to do now is I want to see whether or not u and v satisfy the Cauchy-Riemann equations, and if any one of those Cauchy-Riemann equations aren't satisfied, then my function is not holomorphic. So my Cauchy-Riemann equations are: the partial derivative of u with respect to x must be equal to the partial derivative of v with respect to y. So that's the first Cauchy-Riemann equation. And the second one is that the partial derivative of u with respect to y must be equal to the negative of the partial derivative of v with respect to x. So what this boils down to is essentially just calculating some partial derivatives. So those are the Cauchy-Riemann equations. So let's now find the partial derivative of u with respect to x. So the partial derivative of this thing with respect to x, well, the partial derivative of x squared is just 2x. So that's 2x. And the partial derivative of 2x is just 2. And the partial derivative with respect to x of minus y squared is just 0, because y is not x. So what's the partial derivative of v with respect to y? Well, v is 2xy minus 2y. And the partial derivative of 2xy with respect to y is just 2x. And the partial of minus 2y with respect to y is minus 2. So now we can cancel the 2x's on both sides, and what we're left with is 2 equals minus 2. And we know that this is never ever true. And because this is never true, then this Cauchy-Riemann equation is not satisfied. And because this Cauchy-Riemann equation isn't satisfied, then the function is not holomorphic at any z0 in the complex plane. So f is not holomorphic.